Greetings, statistics students. In today's lesson, we're going to take a look at Chapter 2, Section 2, Density Curves and Normal Distributions. A normal distribution is a very specific type of density curve. So first of all, what is a density curve? If we take a histogram and draw a smooth curve over it, we have a density curve. So we've been doing this pretty frequently with our histograms just so that we can take a look at the shape of the distribution. Remember, this particular shape would be skewed to the right, and this would be an example of a density curve because it's always above or on the x-axis, and the total area under the curve, so the area under the entire curve here, is 100% because we're talking about the entire distribution. So that's what a density curve is. But more specifically, let's take a look at something called a normal distribution. This is a type of density curve. A normal distribution is symmetric and bell-shaped. There's more in the middle and less on the ends. So this is an example of a normal distribution. The mean is right in the middle. I'll label that mu. And with a normal distribution, where we have this about this point right here and over here, so where the function changes concavity, for those of you that have had calculus, it goes from being concave down to concave up, that represents one standard deviation. So one standard deviation to the left and one standard deviation to the right of the mean, that represents 68% of our normal distribution. So 68% of a normal distribution is within one standard deviation. All right, 95% of a normal distribution is within two standard deviations. So if we go two standard deviations out, and I didn't do a very good drawing this to scale here, but you'll get the idea. They have better drawings within your textbook. If I go two standard deviations to the left and two standard deviations to the right, then we have 98% of the normal distribution. So 98% of a normal distribution is within two standard deviations. And 99.7, or almost all of the distribution, is within three standard deviations. So if we go out three standard deviations, we have almost our entire distribution within three standard deviations. So this would be three standard deviations to the left, and this would be three standard deviations to the right. So 99.7%, or almost all of a normal distribution, is within three standard deviations. And I should actually add here, within three standard deviations of the mean, being the population mean. So let's take a look at how this actually works with an example. Let's assume the sleep times of MA students are normally distributed with a mean of 7 hours and a standard deviation of 0.5 hours. Let's first begin by drawing a picture of this situation. So let's draw our horizontal axis here. And then let's draw our normal curve. And we want it to look mound-shaped and approximately symmetric. And in the middle of our distribution, we have our population mean. So for this distribution, our mean is 7 hours. And then we will go one standard deviation on either side of the mean. So about here we'll have 1 standard deviation to the right. And then over here, we'll have 1 standard deviation to the left. So since our standard deviation is 0.5, if I add 0.5 to 7, I'd have 7.5 here. And if I subtract 0.5, I'd have 6.5 over here. So I've just labeled 1 standard deviation to the left and right. And now let's do 2 standard deviations to the left and right. So about here would be 2 standard deviations to the right and 2 standard deviations to the left, approximately. Maybe over a little bit more. So another standard deviation to the right means I add another 0.5 here, I would get 8. 2 standard deviations to the left means I subtract another 0.5, I would get 6. So right now, we're saying about 95% of all students would get between 6 and 8 hours of sleep. 68% would get between 6.5 and 7.5 hours of sleep. And let's mark off 3 standard deviations. 3 standard deviations to the right. And 3 standard deviations to the left. 3 standard deviations to the right would correspond to 8.5 hours of sleep. And 3 standard deviations to the left would correspond to 5.5 hours of sleep. So just a reminder, 68% of a normal distribution is within one standard deviation. So this is 68%. Then 95% of a normal distribution is within 2 standard deviations. So this right here is 95%. And then almost all, or 99.7%, would be within 3 standard deviations. Let me move this up just a little bit so we can have room for me to draw the last little loop here. So from 5.5 all the way up to 8.5 hours, this would represent 99.7% of the distribution. So let's take a look at these few questions related to our distribution. Question 1 is, what percent of students get between 6.5 and 7.5 hours of sleep? Well, since that's 1 standard deviation to the left and right of the mean, I know the answer to this is 68%. What percent of students get more than 7.5 hours of sleep? Well, let's take a moment to think about this. You might want to pause the video at this moment and see if you can figure out what percent of students get more than 7.5 hours of sleep. So we're talking about this area that I just shaded in yellow. So let's think about this for a moment. We know that 50% of our distribution is to the right of the mean, and 50% of our distribution is to the left of the mean. So we have a very symmetric situation going on here. And with that symmetry, we also know that since this is 68%, this right here would represent 34%, and this would represent 34%. So we have 34% of the distribution between the mean and 1 standard deviation to the right, and we have 34% of the distribution between the mean and 1 standard deviation to the left. So what do you think we need to do with the 50%, which represents the entire area to the right, and the 34%? If you said subtract, you would be correct. We would take 50% and subtract 34%, which would give us 16%. One of the things you may be wondering is, does it really matter if we write these as percents or decimals? The answer is it doesn't matter if you write it as a percent or decimal. You can write it either way. All right, what percent of students get less than 6 hours of sleep? Once again, I invite you to pause the video and see if you can think about what percent of the students get less than 6 hours of sleep. That would be this part right in here. Well, let's think about this for a moment. We know that 95% of a distribution is within 2 standard deviations. And right now we're being asked, what is the area to the left of this 2 standard deviation mark? 2 standard deviations to the left of the mean. If you think about it, the entire distribution is 100%. We learned about that a little while ago with density curves. And so if you think about it, if this is 95% between 2 standard deviations, that means we have 5% that's split up between the 2 tails. So if there's 5% in total between the 2 tails, and this distribution is symmetric, we'd have 2.5% in each tail. 2.5% to the left and 2.5% to the right. So the answer to this question is 2.5%. And then finally, question 4 here, what percent of students get between 6 and 7.5 hours of sleep? So that would be here, right? Right. I will give you a second to pause the video and think about this for a moment. So let's think about this for a second. We're asked to find what percent of students get between 6 and 7.5 hours of sleep. So that is between 2 standard deviations to the left. And so we already know that this represents 47.5%. And you might say, why is that 47.5%? Well, remember in our last question, we said the area in the tail here, outside of 2 standard deviations, was 2.5%. And remember, the area to the left of the mean would be 50% of our distribution, and the area to the right of the mean would also be 50% of the distribution. So we can figure out that this is 47.5% by realizing that the area to the left of the mean is 50%, the area to the left of 2 standard deviations is 2.5%, and just subtracting 2.5% from 50%. So this would be the area between 2 standard deviations to the left of the mean and the mean. But the question is, what percent of students got between 6 and 7.5 hours of sleep? So I need to go out here to the right of 7 to 7.5. And remember, 7.5 was 1 standard deviation to the right. And so this is going to represent 16% here, or excuse me, 34%, I should say, not 16%, 34%, because we know that 68% of the normal distribution is within 1 standard deviation, 34% between the mean and 1 standard deviation to the right, 34% between the mean and 1 standard deviation to the left. So to figure out the answer to this question, we just need to add these 2 values. And when we add those 2 values, we get 80, let's see, what is it that we get? We get 81.5%. Well, this is all well and good if every single distribution we worked with only involved working with 1, 2, or 3 standard deviations, but what if we wanted to work with 1.5 standard deviations or 1.25 standard deviations? Well, we actually need a table of values for that. And so now you'll need to grab that blue piece of paper because we'll be using that blue piece of paper for the next little bit. So if we're going to compare different normal distributions, it's easier to compare them if we talk about something called the standard normal distribution. The standard normal distribution has a mean of 0 and a standard deviation of 1. It's very important to know this fact. So you might want to circle it or highlight it in your notes. And what we're going to do then is use a standard normal table to figure out the answer to the question, what is the area to the right or left of a specific cutoff? So before we do this, I'd like you to pause the video and take a look at your standard normal table on both sides and see what it is you notice about the 2 sides of the table. So take a moment to do that. So here we see what's called the standard normal table. And you may have noticed that the numbers in the table are increasing. You may have also noticed that we have 50% right here on both the front side of the table and the back side of the table. That would correspond to a z-score of 0. Remember, if the z-score is 0, that means the value is at the mean, and we'd have 50% to the left of the mean and 50% to the right of the mean. You may also notice that we have 2 decimal places here. So you may be wondering, which side of the table should you use, the front side or the back side? And it depends on whether you're working with a positive z-score or a negative z-score. If you're working with a positive z-score, you'll use this side of the table with positive z-score values. And if you're working with a negative z-score, you'll use the other side of the table. Notice the diagram at the top shows that we're always talking about the area to the left of a specific z-score. Let's take a look at how this table could be used in an example. Let's say we want to know the probability of getting a z-score greater than 1.5. So 1.5 is to the right of the mean, and this question is asking us for the area to the right of 1.5. So I would look up 1.50 in my table. So let's go to our table. And find 1.5. So 1 is here, and I would go 1.5, so 1.5, and then 0 is the second decimal place, which I can see at the top here. So we're talking about a value of 0.9332, but remember, that's the area to the left of this cutoff, 0.9332. So what do we have to do to actually find the area that we want, the area to the right of this cutoff? Well, we would need to subtract that from 1. So 1 minus 0.9332 would be the answer to that question. And so the answer to this question is 0.0668. 0.0668. Let's take a look at some more examples. Let's take a look at another example. In this case, we want to know what proportion of observations are 1.5 standard deviations below the mean. So this statement here is saying what's the probability of a z-score less than negative 1.5. So first I'm going to draw where negative 1.5 would be located, which is to the left of 0. And then I'm going to shade the appropriate area. Less than 1.5 means I would shade to the left. So I want to find the area associated with a z-score of negative 1.5 to the left of that. So let's go to our z-table. And do we want a positive z-score? No, we want the part that has a negative z-score. So let's go back onto the first page, and it was a negative 1.50. So here's negative 1.5. 0 is actually this first column. If we scroll up, we can see the second decimal place is 0. So the area associated to the left of a negative 1.5 z-score would be 0.0668. 0.0668 would be the answer to this question. And you can leave that as that value. If you wanted to write it as 6.68%, you could write it that way as well. Most of the time it's written with 4 decimal places. Let's take a look at another example. Here we want to know the probability of a z-score between 0.25, which would be just a little bit to the right of a z-score of 0, and a z-score of 1. So what we're going to do is first find the area to the left of 1. So we'll find that. And then we'll find the area to the left of 0.25, and then we'll subtract the 2. Let me redraw it this way. We'll find the area to the left of a z-score of 1, and we'll find an area to the left of a z-score of 0.25, and then we'll subtract the two results. So go ahead and take a look at that on the table and see if you can find the values. You can pause the video for a moment. Did you find the z-score values that you needed? Let's find out. Let's take a look at the z-table and look at a z-score of 1. A z-score of 1 would have an area of 0.8413 associated with it, so 0.8413. What about a z-score of 0.25? Let's go back to the table. So 0.25, we can take a look at the row for 0.2 and the column for 0.5, and we have 0.5987. 0.5987. And so to find the area between a z-score of 0.25 and 1, we need to subtract those two values. And so when I take 0.8413 and subtract 0.5987, we end up with 0.2426. So about 25%, so a little less than 25%, 24% of a standard normal distribution is between a z-score of 0.25 and 1. Let's take a look at one more example of this type, and then we'll take a look at an example of one other type. So for this one, we want to find the area to the left of a z-score of 1.45, and then find the area to the left of a z-score of negative 2.4, and then we'll subtract the results. So it's asking us to find the area between z-score of negative 2.4 and a z-score of 1.45. So to find this area that I'm shading in yellow, we'll have to look up two values from the table and subtract, just like we did before. At this point, you should pause the video to see if you can figure out the solution to this problem. So how did you do? Did you get the right values from the table? The value to the left of 1.45, the area to the left of a z-score of 1.45 is 0.9265. The area to the left of a z-score of negative 2.4 is 0.0082. And to find the area between those two z-score values, we'd subtract those two numbers. So our answer to this question is about 91.83%. So about 92% of a standard normal distribution is between a z-score of negative 2.4 and 1.45. Let's take a look at one last example. Here we're going to use the z-table backwards. So we're going to figure out what z-score is associated with the 73rd percentile. If you remember, the 50th percentile will be the same as the mean. So the 73rd percentile would be above the mean, somewhere in here. And we want to know what is the z-score associated with that. So we know the area to the left of the z-score should be about 73%. So now we're going to use the table backwards. Instead of looking up a z-score on the column and the row and finding the area within the table, we're going to look within the body of the table for this value of 0.73. So let's go to the table and let's see. Right now I need to have a positive z-score, so we'll need to use this side of the table. And I want to look within the body of the table for 0.73, and I can see I got two values here. 0.7291, make that a little bit bigger, 0.7291, and 0.7324. 0.73 would fall somewhere in between these. So what is it that you need to do? Well, we're just going to use whichever z-score is closer. So the question is, which value is closer to 0.73? Is it 0.7291 or is it 0.7324? Well, this value is a little bit closer to 0.73. This one differs by 0.0009, whereas this value differs by 0.0024. So this value is a little closer to 0.73. So the answer to this question is that our z-score would be 0.61. So what z-score is associated with the 73rd percentile? It would be a z-score of 0.61. We'll be reviewing more examples like this in class tomorrow if you are in my A period class, and on Monday if you're in my F period class. Have a good weekend and a good rest of the day.